Today we're going to talk about variables and expressions. Okay, we're going to start today's video off by kind of giving you a scenario. Okay, let's say you're going to the store and you and 4 of your friends, so 5 of you total, you want to get a soda and you're being nice and you say, hey, I'll buy all your sodas for you. Okay, so there's 5 of you, 5, and each soda is $1.25 each. Okay, 5 sodas, and they're $1.25 each. Okay, now my question to you is, what's going to be the total price for all the sodas? Okay, well, how do we do that? Well, it's fairly simple. We take the number of sodas, 5, and we multiply by how much each soda is going to cost. Okay, which is $1.25. So 5 times $1.25 is going to give us total of $6.25. Okay. Now, what if you decide that one of your friends doesn't want a soda anymore? There's only 4 of you. Okay, and again, it's $1.25 each. Okay, and you get the total. Again, you do the same process. 4 times $1.25. All right, and you're going to get $5 this time. Okay. What if you're walking to the store and you're going to meet up with your friends, and again, you offer in your group chat or something to buy everybody sodas, but you don't know exactly how many people are showing up. Okay, and so what we're going to use, instead of an actual number like 5 or 4, we don't know how many. We're going to use what's called a variable. Okay, and a variable, it's just a symbol used to represent kind of an unknown or unspecified number or value. Okay, usually use letters, and usually the most common letter for a variable is just x. Okay, it's the most common one. Again, you can use any letter. Okay, and we're doing a problem like this with sodas. Okay, we don't know exactly how many sodas we need. We need a variable for sodas. Okay, but let's just use what makes sense, and let's use S. Okay, we're going to buy an S amount of sodas. We don't know how many yet. And they're still $1.25 each. Okay, ideally we normally write this that, okay, where the number first and variable second. Okay, but what we have here, okay, what we have circled here, it's called an algebraic expression. Okay, and kind of a more formal definition of an algebraic expression, okay, it consists of sums and or products of numbers and variables. Okay, and here we just have the product of a number, 1.25, and a variable s. Okay. All right, some kind of more examples of algebraic expressions. Okay, let's do 2x plus 7. Okay, we have the product of a number 2 and a variable x. And then we have 2x and the sum adding on 7. Okay, that's an algebraic expression. Now, we can look at this, okay, and we can actually, there's actually a term for 2x and 7. Okay, we can kind of break down these algebraic expressions a little bit further. We call these underlined parts terms. Okay, so the terms for this algebraic expression would be 2x and 7. Okay, those are the 2 terms that make up this algebraic expression. Okay, let's look at another one. I'll use a different color. Let's go blue. Let's do 3y plus 4t minus 9. Okay, we look at this algebraic expression. Again, there's just products and sums, and there's a difference here. Okay, this is still an algebraic expression. And we want to find the terms that make up this algebraic expression. Okay, and we look, whatever in the algebraic expression is separated by addition and subtraction, those are the terms. Okay, so we have 3y, 4t, and 9. Okay, and those are the 3 terms that make up this algebraic expression. last part of this section. There's not too much to it, okay? But we're going to talk about being able to communicate mathematically, okay? As you work your way through math classes, and maybe, you know, you might hear an actual like real world problem, or when you're out in the real world that involves math, okay, you have to be able to kind of break down what you're reading or what you're hearing and be able to actually make sense of what is being said or being shown to you, okay? So on the screen, okay, we're going to have a few things written out for you, okay? We're going to kind of start talking about addition first, okay? And as you can see, some terms you might use for addition. In place of addition is more than, sum, plus, increased by, added to. Okay, I'm sure there's more, but those are kind of the most common ones that we'll see. Okay. If I said to you 3 more than a number x. Okay, so we have 3 more than a number x. Okay, well, a number x, we don't have any specific value for it, so I'm going to use the variable x. And 3 more than that, well, I'm just going to add on 3. Okay, if I said 7 more than 5, we have 5 plus 7, okay, we're adding on 7 to 5. Okay, that's addition. Okay, with addition, there's the opposite, there's subtraction. Okay, with subtraction, we have terms like less than, subtracted from, difference, decreased by, minus. Again, those are the most common ones. Okay, x minus 3, right? Or I could say, another way of saying this would be 3 less than x. Okay, we have some number x. We want 3 less than that. Well, if I take 3 away from that variable, that's 3 less than x. Okay, or you know, this could be 3 subtracted from x. Okay, x decreased by 3, etc. Okay, now let's go to multiplication. We just have 2 more. All right, multiplication. We can have the product of, multiplied by, times, and just of. All right, now how do we use those? Well, if we have the product of some number x, and let's say 7, okay, x times 7, okay, this is the same thing as 7x. Remember from that first slide I said usually we have the constant first and then the variable. Okay, this is 7 times x. Okay, these are the same. Okay, if I had 2 multiplied by 100, okay, 2 times 100. Lastly, we have division. Okay, with division, we have ways of saying it like the quotient of or divided by. Okay, 7 divided by some number x, 7 divided by x. All right, pretty straightforward. Okay, some examples, some more examples of how to communicate. Okay, if I said a number x more than 2, okay, take a second, maybe try and think about what that would be. A number x more than 2. Okay, kind of think about the key things I'm saying there. We have a number x. Again, we don't know exactly what the value of that number is. Okay, so that makes it a variable, the variable x. Okay, x more than 2. Okay, so we're at the number 2, and we want x more than that number. Okay, so it means we're going to add on x to that number 2. And it's kind of confusing saying that with variables initially. Okay, if I said 3 more than 2, okay, that means I'm going to have to start with the number 2, and with 3 more than it, that means I'm just adding on 2. Or sorry, 3. We're adding on 3. Okay, so I think that it kind of makes a bit more sense right away when it's just numbers. Okay, but again, it works the exact same way. Okay, let's do one more. If I add 10 less than the product of 4 and some number t. 10 less than the product of 4 and some number t. Okay, so the first thing we hear is 10 less than something. Okay, so we're going to be subtracting 10. So we want 10 less than whatever it is. Okay. The second part is 10 less than the product. Okay, and we hear product, we should be thinking multiplication. Okay, so the product of 4 and some number t. Okay, again, we're going to multiply 4 and some number t. Again, we don't know what that number t is, so we're just using the variable t. So 4 times t minus 10. Okay, that is 10 less than the product of 4 and some number t.